Hello? Can you hear us in Johnson City? No?
Can anybody hear me?
Yes.
Abby?
Yep.
Yes, we're good to go.
You heard me through my computer. I heard you do your through my
No, we're in good shape, bud.
Was the something on there or something?
Yeah.
Okay. When you share your computer, you know your computer will turn.
I did.
Up there. Just by hitting the PC, hitting the computer button. Top left.
Podium PC?
PC, yeah. That'll take this over to here.
Yep.
And it may switch. There it goes. A little slow tonight. Okay. Oh, good.
And then they're there.
It didn't change that, so you can still see them right there. Good. All right.
So the first thing tonight is homework 3. It's going to be due for Tuesday. That's the 12th. So what I did was I picked some problems out of Chapter 3, like the ones I was working on Tuesday. The first 3 I've picked are just multiple choice, 316, 319, and 320. And then I got 327, 330, and 337. Now, I got a little more to say about these problems than just that. Obviously, the multiple choice, you guys are fine with that. You just give me the answer. But for this problem, 327, I'm going to give you, the problem tells you to use the 68, 95, 99.7 rule. Remember, 1 away is what? 68, 2 aways 95, 3 aways 99.7. And then this 3.30, that's going to be like the problems we did on Tuesday. And look, you guys all handwrite yours out, and some of you send it to me in Word and stuff. You got to realize, like, trying to type some of this shit up in Word here is a little difficult. And so what I need from you, if you're going to type it up in Word and not write it out, is I always have these problems where I do, the probability of, or the percentage or proportion. I need to see that part out of you, because you can type that up or handwrite it. And then I'm going to give you, obviously, I need the z-score or z-scores for the problem. You don't have to draw me the pictures. Remember, that was for me just to show you what was going on. And then, obviously, I want the answer somewhere, right? So I expect to know, what kind of percentage or proportion are you trying to find? What was the z-score, the z-scores you use, right? You can calculate those and just tell me what the z-score is, and then I expect your answer, what was that proportion or percentage? And then out of 337, my thought is this. This is, you're going to work backwards. You remember the last type of problems I did on Tuesday? Remember, we did the one where we found the value, put me in the top 15% of miles per gallon or something like that. That was one of them. And then the very last problem I did on Tuesday, I had some normal distribution, and I found the first quartile and the third. I'm pretty sure 337 is asking you, here's some normal distribution, find the first quartile and the third quartile. All right? So that'll take care of the third homework. Now, where we're at is we are in chapter 4, starting chapter 4 here. So before I start, we're getting ready to change parts of the book. I don't know, okay, so they all look like the chapters just string together, but to me, the first 3 chapters went together. And why do I mean that? Because whatever we did in chapters 1 through 3, we looked at a single variable, whether it was categorical or quantitative. And if you really think about what we were doing the whole time, is we were trying to say something about its distribution, right? What values the variable can take and how often it can take them. Yes? Whether it was categorical or quantitative. And even this chapter 3 stuff, when you start talking about a normal curve and all that, we are describing the distribution, correct? Still. So my next chunk of the book is 4, 5, and 6. Now, 4 and 5, I can't distinguish between them at all. That should be just one big chapter, right? Because what's going to happen in 4, 5, and 6 is we're going to take 2 variables now, right? And see if we can talk about a relationship between the 2. Well, 4 and 5, the 2 variables are quantitative, and in chapter 6, they're both categorical. Let me ask you this. Up until now, have we looked at 2 variables at a time in a roundabout way? Maybe at some point we had a categorical variable and a quantitative variable. Remember the homework you just gave me on Tuesday? Read those side-by-side box plots. Categorical variable told you the odor in the restaurant, and then the quantitative variable was the amount of people spent. So we've already done 1 and 1. Now it's going to be 2 and 2. And so 4 and 5, we're going to concentrate on 2 quantitative variables all the way through. All right? So chapter 4, and look, we're getting ready to start over. And what I mean is, how did chapter 1 start? We made graphs, right? And then we made calculations. We're going to start over again. And chapter 4, the title of it is Scatterplots. So we got 1 graph this time, which is nice. And 1 kind of calculation in this chapter, something called the correlation. Okay? So just to remind you what I just said, we're looking to talk about the relationship between 2 variables. Now, I'm going to use some words interchangeably on you. I'm going to talk about relationship. You'll hear it come out of my mouth. Oh, I might say association. So, I'm looking to see if my 2 variables are related in some way or if my 2 variables are associated in some way. So I use those interchangeably. All right? Now, first thing. The first thing I'm actually going to make a big deal about here, or a point about, is it's actually like a dumb thing, but I got to write it down. Measure both variables. Remember, we got 2 on the same individuals. And you're going, dude, you really writing that down? Yeah. Because I want you to think about it like this. Maybe I want to compare people's heights and their weights. Why, surely this shit don't want to take your weights and the ones in Kingsport's heights and start comparing, right? No. I want to take everybody's heights and weights and compare heights and weights across everybody, right? So that's what I mean by measure both variables on the same set of individuals. So what's going to happen now? You've all been using Minitab, right? Yeah. You know, like the first column always gives you some kind of label or something like that. What you're going to see now is, you know, you'll see some like kind of individual's name, and instead of being one column with everything measured, right, one variable measured, there'll be two. So every time you go to anything here, you'll have a collection of your individuals, and you'll have both variables measured on all of them. All right? Now, I got to look at the page 101. I got to read something to you out of your book. I don't know if you guys, it bothers you, me reading or not. It don't really, I'm going to still read it to you. So, all right? It says, a medical study finds that short women are more likely to have heart attacks than women of average age, whereas tall women have the fewest heart attacks. So, look, what they're trying to tell you is there's some kind of relationship or association between a woman's height and her risk of heart attack. Shorter women are more likely to have a heart attack. Taller women are less likely. Did I just give you the relationship or the association between a woman's height and her risk of heart attack? Yeah. Okay. An insurance group reports that heavier cars have fewer deaths per 10,000 vehicles registered than do lighter cars. There's a shocker. So the bigger and the heavier the car, right? So there's something about the weight of the car and compared to how many people die per 10,000 vehicles, right? Is that a shocker? No. Do they got another one here? Here's my thought. I got to write down, I'm not so interested in the one about the weight of the car and the number of deaths per 10,000 accidents. I'm interested in this. Shorter women tend to have a higher risk of heart attacks. And then I'm not going to write down the part about, you know, taller women have a lower risk. The reason I'm writing this one down, see, they're telling me there's a relationship between the woman's height and her risk of heart attack, right? So what happens here when we start studying two variables at a time? Do you really think that a woman's height has something to do with her risk of heart attack? Or are there variables that we just didn't pay attention to that may have some kind of influence or may help explain shorter women tending to have a higher risk of heart attack? See, here's the thing. If I had all these women and I measured their height and their risk of heart attack, are there other things I could have measured that might help me out that we just chose to ignore? And the answer is, yeah, I got two of them here. And I could probably come up with a whole list of them for you. But the two that I have in my mind is, maybe we should have looked at a woman's diet and how much exercise she did, or how often she went to the doctor. You think those things may have an influence on that little relationship about shorter women more likely to have a heart attack? Here's the thing. Before I'm done with this chapter, I'm going to come back and we're going to talk about these variables that we're not even studying, right? But if we paid attention to them, it may really help us. They have a name. I'm just going to give you the name tonight, and then, like I said, before I'm done with these two chapters, I will definitely have this definition out there for you. These are called, the terminology is actually right. They're lurking in the background, right? We're not paying attention to them, but they're there. If we did pay attention to them, it may help us with what we're looking at, right? People do this all the time. I mean, I remember reading one study that if you eat, if you eat like licorice, you'll get cancer. The thing they forgot to tell me was I had to eat like 2 pounds a day. Crazy shit like that, right? So, you had these things lurking in the background that nobody paid any attention to. You understand, right? So we choose to pick two, and we want to talk about a relationship or association, but there's all these other ones out here that may have some kind of influence on that, all right? So just keep that in mind. That's kind of what I want here. Now, turns out we got to give the two variables we're talking about names. So I'm going to do this. I'm going to flip you over here to page 102. And I'm going to kind of go at this like this. There's two names I want to give you here. One is something called the explanatory variable. And the other one is something called a response variable. We're thinking about...
Do it today. Oh!
Interesting. Okay? So if I come over here and I look at the definition on page 102, a response variable says measures an outcome of a study. So the way I think about the response variable is it's something you measure after the fact, right? It's a response to something. And then the explanatory variable, an explanatory variable may explain or influences changes in the response. So explanatory means explains, influences. In other words, sometimes the two variables play different roles, right? We think about one being the explanatory, one is doing the explaining or the influencing of the response, and the response is what I think about it like this. The explanatory variable does the explaining or the influencing, and the response is the variable that's being explained or being influenced. All right? Now, do we always make this distinction? And the answer is no. But go back to my shorter women having a higher risk of heart attack. You might want to think about the woman's height as being the explanatory variable and the woman's risk of heart attack as being the response. Remember the one about the weights of the vehicles? We might want to think about the weights of the vehicles being the explanatory and the number of deaths per 10,000 vehicles as being the response, right? Can I give you the one that you'll never forget? It's example 4.1. It says, how does drinking beer affect the level of alcohol in your blood? I'll continue. The legal limit for driving in all states is 0.08%. Student volunteers, imagine getting to be a volunteer for this, at the Ohio State University drank a different number of cans of beer. Then 30 minutes later, a police officer measured their blood alcohol content. So let me ask you this. Do you think the number of beers you drink helps explain your blood alcohol level? Everybody remembers that. So what are we thinking? We're thinking the number of beers you drink as being the explanatory variable, right? And your blood alcohol level being the response. Yes? Let me ask you this. Take that one step further. If I change the number of beers you drink, can I change your blood alcohol level? Sure, the more beers you drink, the higher the blood alcohol level, right? I can change that, right? So not only does it influence or explain your blood alcohol level, but if I start making changes in the number of beers you drink, I can actually cause a change in your blood alcohol level, right? So that's kind of like the next step there. Now, one more. I got to look at the next one, right? So it all depends on, look, how people look at it is the next one here. And it says college debt. A college student and aid officer looks at the findings of the National Student Loan Survey. She notes data on the amount of debt of recent graduates, their current income, and how stressed they feel about college debt. She isn't interested in predictions, but is simply trying to understand the situation of recent college graduates. The distinction between explanatory and response variables does not apply. So here's the thing. You see these two things here? I think about this one explaining or influencing that one. That's one time we make a distinction where we think this one explains or influences that. If we want to predict the value of one variable from the value of the other variable. Look, that's just a way of me saying, look, I want to take one of the variables and I want to use it to predict the other variable, right? Well, anytime I do prediction, anytime you see that somebody says, okay, I want to use this one to predict that one, we always have to make an explanatory and response distinction, right? I need to call one the explanatory and I need to call one the response. So you see this, you see the one that we're trying to, that's the one we're trying to predict, right? That will be your response. You see this one here? from the value of the other, that's going to be your explanatory. So, it may be we think, so I got like two things going on. It may be I think one explains or influences the other. I got to have explanatory and response. I might want to use one variable to predict the other. I got to have explanatory and response. The variable you're using to make the predictions explanatory variable, the variable that is being predicted, that will be your response. If I don't have those, I just got two variables, right? And I'm looking to see if they're related. I don't always have to make that distinction. Okay? Then this problem says, a sociologist looks at the same data about student debt with an eye to using the amount of debt and income along with other variables to explain the stress caused by student debt. Now you got explain, right? Influence. You got one's going to be the explanatory and the other one's going to be the response there. Okay? So are we okay? So let's do this. Let's go to page 103 and look at problem 4.1. I'm not going to write it down for you, but I'm going to tell you, okay, let's look and see if we can do this. 4.1, right? Example. So it says, explanatory and response variables. You have data on a large group of college students. Here are 4 pairs of variables measured on each student, on these students. For each pair, is it more reasonable to simply explore the relationship between the two variables, or is it better to think about one as being the explanatory and the other as being the response, right? In other words, do we need to make that distinction? It says, in the latter case, obviously, which is the explanatory and then which is the response. Part A, the number of lectures attended in your statistics course and the grade on the final course. Do you want me to give you the answer to that one? Do you think one of those explains or influences the other? Yeah, I'm hoping you think so, right? I'm thinking the number of lectures attended in your statistics course helps explain your grade on the final exam. If it doesn't, then I'm kind of wasting my time here, right? So the number of lectures attended, that would be the explanatory variable, and the grade on the final exam would be your response. Number of hours per week spent exercising and calories burned per week. That's almost like the drinking the beer and the blood alcohol level, isn't it? Right? So I would think that the number of hours per week spent exercising should be your explanatory variable, right? Because that helps explain or influence the calories burned, the response rate. 3, hours spent online using Facebook and your GPA. Do you understand why some of these are actually in the textbook like this? I got that thought again. I actually think one explains or influences the other. I could be wrong, but I'm going to go with one explaining or influences the other. And I'm going to say hours per week spent using Facebook would be explanatory and your GPA would be your response. And I don't really know if that's true or not, but that's the way I would look at it, right? And then the last one, hours per week spent online using Facebook and a person's IQ. I'm sorry. I think we should probably just look to see if they're related. I don't want to say out loud that the number of hours spent on Facebook is going to help influence or explain your IQ. I don't want to say that, but maybe they're related in some way, right? So we'll just call it, all right, we got 2 variables. We'll just see if they're related, all right? Now, we got one graph here, and one graph only. And my graph here is, this 4.2 here is displaying. Are we okay so far? We making a little bit of sense tonight? So my graph for displaying relationships is Scatterplot. Okay? That's my guy. Now, I haven't written this down up until now, but now we're looking at 2 quantitative variables. All right? So, one more time. If we're looking at the relationship or association between 2 quantitative variables, our graph to be made to look at that is a scatterplot. All right? So, instead of me sitting here going, okay, so scatterplot this or scatterplot that, I would like to read something to you out of the book on page 103. There's a box there, all right? And it's how we set everything up. And it says this. A scatterplot shows a relationship between 2 quantitative variables. You already got that written down right here, okay? measured on the same set of individuals. We had that talk. The values of one variable appear on the horizontal axis. The values of the other appear on the vertical. In other words, you know how we made like bar graphs and histograms? I got an X and I got a Y, right? So one of the quantitative variables will be on the X and the other quantitative variable will be on the Y, all right? It says each individual in the data appears as the point in the plot fixed by both the values. In other words, scatterplot is just dots. How are they fixed? Well, every point in there represents an individual, and every individual has two values, one for each one of the variables, and that's how you fix it on there, all right? I'm going to show you that in a minute. Always plot, this is the part that's important, always plot the explanatory variable on the x-axis or the horizontal. If you have explanatory and response, the explanatory always goes on the x, and the response always goes on the y. That's for the next chapter. One more time. If you've got that distinction, because you thought one explained or influenced the other, or you want to use one to predict the other, the explanatory goes on the x, and the response will go on the y. If we're just looking to see if they're related, put one here on the x and put the other on the y, and nobody cares. All right? Example 4.3. I got to do about one little dot to show you how the software is going to make the scatter plot for us. So I didn't ask you guys too much. How do you feel about using this software to make the graphs and stuff? It's way better than me sitting here trying to draw that crap out, right? Okay. Figure 1.8 on page 27 reminded us that in some states, most high school graduates take the SAT to test their readiness for college, and in other states, most take the ACT. In case you forgot, on page 27, it was a histogram, and it was a histogram where we showed you the percent taking, I think it was the SAT test. Remember I had those two chunks? I had the chunk over here and the chunk over here? And then remember I told you the chunk that had the lower percentage was really the ACT states, and that was the SAT states? All right. It says, who takes the test may influence the average score. Seems like a reasonable thought. Let's follow the four-step process. I don't care about that. Here's what I want to do. State. The percent of high school students who take the SAT varies from state to state. So one of my variables is percent taking the SAT. Right, I'm going to put SAT here. Right, obviously, we start changing states, that percentage changes. Yes? And then what we would like to, else we'd like to measure, we would like to look at the average SAT math score for each state. Okay? So those are two variables. Remember, it said maybe who takes it helps explain the scores, right? So we're looking at the percentage taking it for who takes it, and then we're looking at, okay, how did they do? We're looking at the average SAT math score, just looking at something, right? So I think that this one should be your explanatory, because I think the percent taking will help explain or influences the response. Right? So again, the explanatory is going to go on the X, and the response is going to go on the Y. Now, I need one state here because I don't have a table. I know where I can find the table. And what do I need? I need all 50 states listed, and I need the percent taking the SAT in each state, and I need the state's average SAT math score, right? Well, let's see if I can find it here. Because, you know, I always start that guy up for you guys. I always have it ready before you get here or there. Let's see. Chapter 4. What am I looking at here? 4.3. Okay, so there's my information. Notice the first column is the 50 states. Notice the District of Columbia is in here, so I'm assuming I got 51, right? There's 50 states, the District of Columbia. What do I have for each one of them? I have the average SAT math score for the state, and I have the percent taking the SAT test. Everybody follow that, right? So if we pick a state here, and we can pick any state you want. Well, let's go to our state here. Tennessee has an average SAT math score of 574, and the percent taking is 8. Did I read that correctly? Right? So if I come back here, and I look at Tennessee, for example. Okay? What was it? 8% taking. and a math score of 574. Okay? Now, I could do that for any one of the 51 individuals, right? In other words, I have both variables measured on all of them. And so if I was crazy enough to sit here and go, okay, so how do I make a scatter plot by hand? What goes on the X? I got an explanatory variable, right? So here's going to go the percent taking. What's going to go on the Y? The average state mass score. Are we okay with that? Now, if I was doing this crazy shit by hand, I'd have to chop all the axes up, right? Like things like equal widths and stuff. I'm not going to do that. How would I put Tennessee on my scatter plot? Well, 8% was taking, and 574 was the math score, I think, right? 8% taking, 574. So you would find, just for that one state, I would find where 8% is here, right? And then I would find where 574 is here. I put a dot. What that dot represent? That dot represents Tennessee. Now, all you're going to see is dots. Nobody's going to label it like this, but this is Tennessee. And I got to show you, because I don't know what kind of math minds we have, but that's fixed by 8, 574. In other words, I have a value of X and I have a value Y, and that's how I put my little dot on them. Everybody okay with that thought, right? So I got to do that for all 51 of my individuals. When I'm done and I'm looking at this scatter plot, how many little dots should be on there? That was a loaded question. Shouldn't there be 51, one for every individual? What would stop me from not having 51? If there was two states that had the exact same percent taking and the exact same average mass score, there'd be one dot representing two states. Other than that, every dot should give me an individual, and I'm going to give you, obviously, there's not going to be two states with both the variables the same value, right? So there should be 51. We okay with that? Okay. So, the book doesn't waste time. They come over and they make the scatter plot. So I'm going to go ahead and make the scatter plot for you, and it's not, if you don't mind, it's not going to be there. It's going to be here. Notice, first column is my individuals. The second column is the average math score. The third column is the percent taken. So where would you think that a scatter plot would be? Well, look at the drop-down menu. Shit, it's the first one. Nice. Scatter plot. What kind do you want? I always, at this point here, I just want a simple one, right? So it's already, I can pick any of these. I'm just going to pick the simple one. I'm going to click OK. Now, here's the screwed up part. It's asking you which is your Y first, and then it's asking you for your X, right? So the Y is the response, and the Y is the math score, and it jumps over what's the X, what's your explanatory variable. It was the percent taking. That's all me and you got to know to make a scatter plot. Is what one do I want to put on the Y, and which one do I want to put on the X? Minitab asks you for the Y first. All right? You understand if we flip-flop them, things are different, right? Okay? So, and then all I got to do that was like a 2-second operation. If you don't think that's a good idea, when you go home tonight, get that little file up, take every little dot and put on. I know you're not going to do that, though. I showed you that, right? Okay. Now, let me ask you this. You think I could pick out which one represents Tennessee here? I'm going to give you this. That guy must be somewhere in... If I had to pick... Oh, I'm just reading the 574 and it's around 8. But nobody cares. See, that's one of the things is we kind of lose that. But all 51 of them's on there. Are we okay with how to make a scatter plot? And I'm going to scream at you one more time. If you've made the explanatory and response distinction, explanatory goes on the X and the response goes on the Y. Right? If you're thinking you're going to use one to predict the other, the one you're using to make the prediction is the X, and the one that is being predicted is your Y. All right? Now, here's the thing. There's only one graph. That was your guy. So, interpreting. And I should say interpreting Scatterplot, but it's interpreting. There's only the one there, so I'm not going to say that. And what I'm thinking about is I'm talking about examining. A scatterplot. Hey, I got a question. Is my handwriting any better when I'm here? I mean, it's never good. No, I was just thinking the pen felt better for some reason. So, let me ask you this. When me and you interpret a histogram, what's the four things we always want to talk about? Shape, center, spread, outliers, right? Okay, so I'm going to kind of give you the same setup as I did there, but it's not going to be like center and spread and all that. One, what I'm looking for is I want an overall pattern. That was the same thing I wrote about a histogram. Striking deviations Okay, so I'm going to do this. This is like number 2. When we talk about an overall pattern, okay, so there's 3 things here. I want to talk about direction. In other words, the direction you see in the scatterplot, or the direction of the relationship. Form and strength. All right, so that takes the place of shape, center, and spread. And then this one here is going to be number 3. And these striking deviations, it's still the same terminology. So 3 here is still outliers. Okay? So when you look at a scatterplot, we like to talk about direction of the scatterplot, the form of this scatterplot, and the strength. And then we also want to talk about outliers. Now look, for me and you, until we get to like the end here, we're going to focus in on those 3. And then we'll have a talk about outliers before all this is said and done. Okay? Now, I can come right here, and I would like to look at that guy, because that's the scatterplot. Now, do you see how the points look like they go from upper left to lower right in the scatterplot? Right? You know, if I was to be crazy enough to draw something in here that looked like that, they go from upper left to lower right. So the direction here, and I'm going to write all over this here, since it goes from upper left to lower right, that's just me saying that. That's not the terminology that people use. The terminology is something called a negative association, a negative relationship. All right? Let me ask you this. This is like telling everybody when you're in your, in your histogram and you're telling me that it's skewed to the right. You know, there's a tail going out to the right. Remember, that's what you saw in the histogram, but that actually told me something about the distribution. Well, me telling you that these points go from upper left to lower right and giving that a name called a negative association, that's telling me something about the relationship. It's telling me, and here, I'm going to quote the definition out of your textbook. Above average values of one variable tend to occur with below average values of the other. Right? And below average values of this one tend to occur with above average values of this one. What the hell does that mean here? See, I can brainwash you into upper left to lower right as a negative association. That doesn't tell me anything about the 2 variables in the relationship. So what I'm saying is this, and I'm going to change colors and go, you see how these states here, those are the ones that have above average values of their state math score, right? Well, what's their percent taking? They have a low percent taking, right below average. So states that have a low percent taking the SAT have a above average SAT math score, yes? You see these down here? Here? These are the states, the ones out here on the right, those are the ones that have a below average SAT math score. What do you notice about the percent taking? They have above. I just gave you the definition in terms of the two variables and seeing a negative association of what negative association means. Above average values of one variable tend to occur with the below average values of the other and vice versa, right? What does that mean here? That means states that have a below average value of percent taking it have an above average value of SAT math score. States that have a above average value of percent taking have a below average value state math score. You understand why my hands are moving like this? Because it's the blues and the reds. I'm here and here, and I'm here and here, right? There's above average values of that one, below average values of this one. Here's below average values of that one. There's above average values. Anytime you see a negative association, that's what you're telling me. The points go from upper left to lower right. What does that mean? They occur opposite of each other, right? Above and below, or below and above. Yeah. I got to look at you again. Because, I mean, I can have you, it's the same as always, is the directions telling me what the hell you're seeing in the scatter plot. Oh, yeah, negative association. Right? So what the hell does that mean? How about if I put it to you like this, and we see this negative association? If I told you that we increase the percent taking as we go from left to right on the bottom, what happens to the value of the average state math score? So, you know, I go from somebody having 8% to 16% to states that have 60, 70. What happened to the state's mean math score? It went, yeah. So another way to think about negative association is if I increase the value of your explanatory variable, I'm going to decrease the value of your response. Is that the same thought, same idea? And the answer is, yeah. It's just another way of looking at what the hell a negative association is. Yes? Okay. I got to come back here. So that's the direction. I'm going to wipe all that out. And then somebody's going to want to talk to you about a form. Now, I'm going to give you the heads up. Me and you're going to have a favorite form here before all this is said and done, and it's going to be linear. Didn't you think it was strange I drew that red line on there to start with? Yeah. That's going to be our favorite, and we're going to measure everything against that. Okay? So the first thing I see here, if I want to talk about form, off to the side, okay? And I got to be honest with this one. Like I said, me and you're going to try to put a line on everything we do. That's going to be our goal. That's going to be our, you know how like density curves, our favorite ones are normal? You know that now, right? After chapter 3. Yeah, so my favorite form when I'm looking at scatterplots is going to be linear, okay? So my problem is, if I had to draw your line in here, oh, I'm sorry, but I got to draw it with a slight curve to make things really look right, yes? So it's linear to a point with a slight curve. Okay, to be honest with you, if I didn't have linear stuck on my brain all the time, what I really see here is I see two clusters. I see that chunk on the upper left-hand corner, and I see this chunk down here in the lower right. So another way to think about it is two clusters. And if I didn't have linear stuck on my brain all the time about looking at this particular kind of form here, I would just tell you I saw two clusters. Can I ask you a question? Which states, remember we have some SAT states and we have some ACT states, right? Do you think that's my two clusters? What's the one in the upper left? That's the one that have a low percent taking the SAT test, and that's the one that has a high. If I had to bet money, right? The one that has a low percent taking it and the high average math score, that's the ACT state, because in ACT states, the higher percentage takes the ACT test, right? The ones here in the lower right-hand corner, that should be the SAT states because they're SAT states, so the higher percentage take the SAT test, right? Are we okay with the form? I gave you two choices. I always have linear stuck on my mind, but the truth is these are two clusters. Can I ask this question? You got any thoughts about why we're seeing what we're seeing? Not the fact that I know I have ACT stage and I have SAT stage, right? Why am I seeing, when I have a low percent taking the test, the average math score is higher? When I have a high percent taking it, the average math test score says lower. Why am I seeing that negative association like that? I know why I'm seeing the clusters. Why am I seeing that? Well, I don't want to hurt your feelings, but it's the same thing that happens in Math 1530. If I had all math majors, what would be the grade? It would be very high. It's a core requirement, right? I got art majors, history majors, business majors, math majors. You understand, when I get a whole bunch of all different types of people taking some kind of test, what happens to the score? Nothing personal. They go down. See, these ones that are low percent taking it, those students there, they have a purpose. Not that you guys don't, but, they're wanting to go out of state or something like this, so I'm thinking, they're going to have a better score, right? It's that same thing all the time is, anytime I take a test and I get everybody and their brother taking it, instead of some specialized group like math or something like that, the scores are going to be lower. It's just a given, right? So I'm not shocked that I'm seeing this negative association. Now, I'm going to clear this out, and then you got to give me the benefit of the doubt on the next one, right? Because remember, there's a 3. The third one is strength. And I'm very wishy-washy. You wouldn't think that being with me 8 classes, right? I don't seem wishy-washy. But every semester when I get there, we're going to talk about how strong is this relationship. What they're asking you is, and I'm going to write it up here, is how close do the points. Now, you understand when I say points what I'm talking about. Remember, the points are the actual individuals in your data set. Follow, how close do the points follow the form? The closer they follow the form, the stronger the relationship. You saw my hands move? Yeah, I had that line up there. The closer those points are to that form, the stronger it is. You see how I got those clusters? The tighter they'd be in here, the stronger it is. So the best I can do here is, remember, I did pick out, that says something. I can see 2 clusters, right? And so the best I can tell you here, and I apologize, wishy-washy, I start throwing the word moderate in. Well, it's not really strong. It's not weak. Shit, it's somewhere in the middle. It's on the moderately strong side of things, right? I can see it. I can circle them. I'd like for it to be, and I'd be talking about real strong, right? So it's moderately strong. Now, so far so good with that one. That was our first go at any of these. So I'm going to come back here, and what I would like to do is, I would like to talk about negative association, again, in general, right? What does it mean when that's my direction? So I'm going to give you the scatter plot, and my typical scatter plot would look like this. Oh, I forgot to tell you. If you let me draw one for you, I'm going to draw one that has a linear form. Right? So again, you see how it goes from upper left to lower right. I'm reading from left to right here, yes? And I'm going to say above average values of this occur with below average values of that, below average values of the response, above average values there, right? That was the same thing I did, and that's in general. So upper left or lower right, that's a negative association. And then in terms of what are you telling me about the relationship, above average values of one variable occur with below average values of the other, and vice versa, right? So we already saw that. But you got to realize if there is a negative association, there is a positive one, right? So what would the scatter plot look like there? again, I apologize. I always have linear form on my mind. And I'm actually pretty good at drawing, right? So you'll notice here, they go from lower left to upper right, yes? And so how do the values match up as far as below average and above average? Notice, below here, below there. Above average values of the explanatory, above average values of the response, right? So they go the same that way. Another way to think about positive association, if I increase the value of your explanatory variable, what am I doing to your response variable? My hands are telling me. If I increase this way and I see a positive association, I'm going to increase the value of your response. What was the negative? If I increase your explanatory value, I'm going to decrease your response, right? So I think what I should do for you is, if I'm going that way, I'm going that way, right? If I increase the value of the explanatory variable and I see a negative association, I'm going to decrease the value of the response. And over here, if I go that way, I'm going. Does that help a little bit, right? So that means a positive association. As we start increasing the value of the explanatory variable, we're going to increase the value of your response, right? So that's a positive association there. Now, what I was thinking is we need to see one that looks like this. And so we can take a look here at example 4.5, and I've got the file here. I wanted to show you how to make another scatter plot. So here's what I've got. In example 4.5, it says, manatees are large, gentle, slow-moving creatures found along the coast of Florida. Anybody ever seen a manatee? Uglier than hell. Big, but ugly. Slow, big, ugly. Right? It says, many manatees are injured or killed by boats. Sorry, I apologize up front, but that's a fact. Table 4.1, which is on the bottom of the page, contains data on the number of boats registered in Florida in thousands and the number of manatees killed by boats for years between 1977 and 2015. Who are the individuals here? It's the years, right? From 1977 through 2015. Those are your individuals. The individuals here are actually the year. Why am I saying that? I don't want you to have some kind of time plot on your mind or something, right? So the individuals here are the different years from 1977 to 2015. What do we measure for all the years? Number of boats registered and the number of manatees that it's killed, right? So there's two quantitative variables here. It's the number of boats registered Now, I have a question for you. When it says in thousands, right, so it says, okay, the number of boats is registered is in thousands, and I look at the year of 1977, and it says 447. How many boats were really registered? Thousands. Multiply by 1,000. Add me 3 zeros. There was actually 447,000, right? Okay? And then the other variable is, what was it, the number of manatees killed? So I got a bad question. Do you think one helps explain or influence the other? I kind of do. I kind of think, remember, they're slow, gentle, ugly in the water. I think this helps explain this one. Right? I think the number of boats registered will help explain the number of manatees killed. Now, what we would like to do is I'd like to make a scatter plot, and what do I want to look at? I want to look at direction, I want to look at form, I want to look at strength. Remember, I've ignored outliers up till now. We'll eventually get to that. So if I come over here, and I get rid of this one, and I find that file, what is this? This is manatees. So, again, notice the first column is the year, that's the individuals, and I have the number of boats registered, and I got the number of manatees. The only thing you got to be careful about when you make the scatter plot, right, remember we just want a simple one, is it does a weird thing. See, I always have X in my mind first for some reason. The reason I have X in my mind all the time first is I'm a math guy, right? Anybody know the equation of a line? I know, we're not all math majors. You remember like the slope-intercept form, y equals mx plus b? No, I'm always worried about somebody giving me an x so that I can spit you out a y. So x is always on my brain first. Unfortunately, Minitab, y is on its brain first, right? So what's the y here? So I just click in here, and the y is kills manatees, right? And then boats go in the x. We okay? Right? So the y was the number of manatees killed. The x was the number of boats. And then you notice I don't have to change anything here. Now, is that different looking than the one about the SAT percent taking and all that? Yeah, right? So if I had to ask, what would you tell me your direction is here? Folks, to be honest with you, this is about as good as it gets as far as like seeing what you need to see. Is that a negative association or is that a positive association? That's lower left to upper right. Yes? So that is a positive association. Now, I'm going to put my pen down. You're going to write that down, and I'm going to look at all of you folks in Kingsport. I'm going to look at all you folks here. So what you just told me is what you see in the scatter plot, right? I see the points go from lower left to upper right. What's a positive association mean in terms of these two variables in the relationship? You understand? You're getting ready to tell me what the relationship is, right? When the years where you had a below average value of the number of boats registered, there was a below average number of manatees killed, right? In the years, I'm sorry, but I got that little scatter plot right in front of me here, and my hands are moving, right here and here. Below average values of the number registered, below average number of kills, right? Above average values of registered, above average values of killed. It's that red and blue I drew you in general. How about if I interpret it like this for you, that positive? If you increase the number of boats registered, what happens to the number of manatees killed? You increase this way, you increase, right? So when there's more boats registered, there are more manatees killed. Yep. Okay? Now, get rid of that one. What was my second thing? I ain't got to talk no trash about no clusters here. You give me a big-ass magic marker, and I'll draw you a heck of a line on there, right? Yeah. What's it look like? I'm going to tell you we're linear. You agree with me that time? Yeah, that's very good. Actually, it's so good, I'm going to apologize. I'm going to get rid of I will just leave it there. Scatterplot. Now, you see, I got the simple one, which is the one I keep showing you. I don't worry about the one with groups. You see the one where it says with regression? Regression is a term we're going to talk about in 5, but what it's going to do is it's going to put a line on you, right? So what about if we do that one? And then that might stop me from having to draw. Remember, Y is the number of kills, X is the number of boats. It looks like almost the one I drew through it, right? Except that's what we got, yeah? So what kind of form we see in here? Linear. Do I need to ask? How strong is it? This is not going to be me being wishy-washy here. I'm going to tell you that's strong to very strong. So I'm just going to give you strong, right? There's nothing moderate about that. Actually, you can see it, and you can stand there and look at it, and you can see the linear form. Forget that I drew the line, and you can see they're following that linear form very nice. There's no clusters or anything. That's way better than the one before, right? The only other thing here at this point is this. And I'm just going to say it out loud, and then I might come back next week and show you one of these in Minitab. But it turns out we can talk about adding a categorical variable to a scatterplot. Okay? And the way you would do that and you're not going to do it by hand, so it won't matter. The way Minitab does that for you is it either changes the color, right? So you make, let's say you got some categorical variable that has two categories, right? So you can change color or change the symbol. Instead of using dots for part of them, you use plus signs or something, right? Or little squares. And then it has to be something on the right-hand side here that gives you a legend that says, you know, all those little black squares are this group. All these little red dots are these. All these little green triangles are these, right? So you can add a categorical variable to a scatterplot. Now, let's see if I want to look at another problem here. Now, I'm going to give you a heads up. The scatterplot's not near as good as, let's say, the one I just looked at, but I want to show you about adding a categorical variable, right? So I want to look on page 110, and it's Apply Your Knowledge 4.9. And again, the warning is the form is really hard to see, right? But I want to show you how to add a categorical variable. It says this: death by intent. The data described in exercise 4.4 earlier also indicated that the homicide rates for some counties should be treated with caution because of the counts. So here's what I've got. I've got counties in Ohio, and I have two things listed. I have homicide rate and suicide rate in those counties, right? And I forget how many counties are there, but that's what I have, okay? And then the other thing they've done is they've added, like, there should be a caution because of low counts. In other words, you know, we didn't have enough individuals in the data set, but there should be caution. So they gave you like a little yes or no, and the little yes or no is a categorical variable, right? And so part A says, make a scatterplot of homicide rate versus suicide rate. You see that language? Versus? Anybody ever seen versus before? So to me, it's usually Y versus X. So they're trying to tell me to let the homicide rate be your Y, and your suicide rate be your X, right? Y versus X. One more. Y on X. Instead of putting versus, they just put the word ON in there, right? So Y on X, Y versus X, okay? For all 26 county, use separate symbols to distinguish between the ones where you should be having caution or not. In other words, the ones that said yes or no. So if I come over here, this file here, we don't need that guy. I don't need that guy. That file is 4.9. Now notice, it's got all 26 counties, and I think these, if I remember right, these 26 counties are in Ohio. It has the homicide rate, the suicide rate, and whether the homicide rate should be used, should have some caution, right? So, again, we're going to go to Scatterplot, except this time, do you see the second one over where it says with groups? That's where you're going to add the categorical variable. All right, so I'm going to choose with groups. All right, and remember, I'm supposed to use, what was it? Y versus X. Y was homicide rate, so Y is homicide rate, suicide rate, and then it wants to know where's the categorical variable that you want to put on your scatter plot, and the categorical variable is the homicide caution, right? The yes or the no. So what does Minitab do? Okay, so the ones that said no is that blue, and they're like little diamonds, and the ones that said yes are like little squares or red. If we add a categorical variable, can you pick it out? There's a little legend on the side there. That's your guy, right? Okay. It says, does the same overall pattern hold for both types of counties, the ones that are yes or no? And I apologize to you folks in Kingsport, but I got to walk over here for a second to move. And I want to be honest with you. When I stand back here with you guys and look here, I don't see shit. Man, and it is a little blurry. You're right. It's the lighting in the room is the problem. Yeah, is there an overall pattern of period? I see a pile of crap. I got dots everywhere. Right? I mean, we want to talk about some overall pattern here, some overall pattern there. Well, I guess there is an overall pattern if you want to think about it like this. You see all the red ones are along the bottom, right? And then all the blue ones are kind of on the top, right? So at least if the ones said no, and you started increasing the suicide rate, you kept like a kind of a constant homicide rate, right? And the ones that are in red, you know, you might have a change in the suicide rate, but I mean, you have a low homicide rate, but at least it stays constant across them, right? In other words, what I'm saying is you went here and sorry. Right? I'm sorry, I just wanted to show you how to add a categorical variable. The data, I mean, it's real life data, and when it's real life data, things aren't really good, and that's not really good. But everybody see the red squares and the blue dots? Perfect. That's my main thought here. All right? Now, before we go home, we're not really ready to go yet. We might go home a little bit early. I apologize up front for that, but I got a thing. No, I did want to come see you guys anyway. It wasn't just because I had a thing to do. You like me better here? Or not? See, but they like me better there. So we're going to have to go back and forth. So. All right. So now, remember the title of the chapter, there was two things, right? There was a scatterplot, and then there is a correlation, right? So now here comes my calculation. So I'm going to be very loud with you here. Measuring linear association. Okay? In other words, what I need is I need some kind of calculation that will tell me about the direction and the strength. Can you already tell that the form is given here? Is the form written up there? That's my favorite. So what we're getting ready to calculate is going to tell me something about a linear association, a linear form, right? A linear relationship. Now, I've got this big old formula over here. And correlation always is denoted the same for me and you. It's denoted by a little r. Sometimes people will call it the Pearson correlation. Little r is correlation. Now, here's the thing. The calculation looks like this. So if you've got n individuals, or if you like n observations, remember you got two quantitative variables measured on all of your individuals, right? That's the way we started here. You take 1 over n minus 1. So you're going to take some, it looks like some kind of average here, right? You're dividing by n minus 1, one less than the total number. And then we're going to add a bunch of things together. Remember, that's that capital sigma. We're going to add these things together. And what we're going to do is we're going to take all the x's. Remember, there's an x variable and a y. For the x's, you're going to subtract off its mean and divide by its standard deviation. And for the y's, you're going to do the same thing. Now, I'm going to write something here before I go and start talking about this anymore. You see this? X bar, that's the mean of the x variable, right? So you got the x. Y bar, that's the mean of y. You see this S subscripted with the x? Remember, we use S for standard deviation of x. S subscripted with a y is the standard deviation of all the y variables. You shouldn't be shocked. You've got two quantitative variables. There's two means and there's two standard deviations. That's what I'm writing down there. Now, so it looks like you're... Can I ask a question from like Tuesday? Those look familiar? What did I do where I took a value of the variable, subtracted off a mean, and divided by the standard deviation? Is that a z-score? Now, I'll give you, this time we're standardizing. We're not using mu. We're using the actual mean of the x's, right? And we're actually dividing by the standard deviation of the x's. But what I have circled there in red is that's the standard values of the x's. And what I have circled in blue is the corresponding standard value of the y's, right? So we are standardizing. Yes? Do you remember in chapter 3 when we standardized, it removed all the units, right? Because the standardized is telling you the number of standard deviations away from the mean you are, yes? So if you're measuring things in inches or feet, all that shit's out the window, okay? So, note, we standardize the values, and I mean X and Y values, so units won't change your correlation. So in other words, I started with like your heights and weights, right? So if your heights are in inches and your weight is in pounds, I can calculate this correlation, right, for everybody that we have here by doing that big old formula I had at the top of the page. Suppose I changed your heights to centimeters and your weights to kilograms. Am I going to get the exact same value of the correlation? And the answer is yes. So changing the units will not change the value of the correlation because we do that little standardization, right? Okay. Next note. And I don't know what color you want me to write it in for you, but you can't forget this one. The correlation, that formula, little r, measures only the strength and direction of a linear relationship. Now, I'm going to underline some stuff for you here. We're only looking at linear. It only tells me about linear. If it's any other form, correlation won't tell you anything about it. But what does it tell me about it? It tells me the strength, how strong it is, how close the points follow the linear form we're looking at, and it tells you the direction. Are you seeing a positive association or are you seeing a negative association, right? The reason I underlined all that and circled that, that's my three things about a scatterplot, right? Direction, form, strength. The correlation will tell me about the direction and strength, and we're looking at a linear form. It's going to tell you how strong all of that is. Now, can I back up for 1 second? To here. Now, you know that this formula there's no way we're going to pull this out and do this by hand, right? This is going to be all done in the software. It'll be all done on Minitab. In other words, anytime that you need to be able to calculate, you'll have Minitab at your hand. If I wanted to give you something on a test, hell, I'll just give you the correlation and start asking you questions about it. The calculation don't mean anything to me and you, right? I mean, I can stand here in the next 45 minutes and do one. That's not going to get me and you where we need to be, okay? So, a couple notes here, all right? And then these facts. Now, these facts are just as important as any calculation me and you would ever make, okay? The first one is R makes no distinction between explanatory and response. Translation, the correlation does not care that you called one of the variables an explanatory variable and the other variable the response. It does not care that you put one on the X and one on the Y. It does not matter to it. In other words, with the correlation, if you flip-flop them, you'll get the exact same value. Two, we need R needs two quantitative variables. See, it makes it very difficult to calculate the correlation between a person's gender and their yearly income. I have a hard time putting that little M or F in that formula, right? So you've got to have quantitative variables here. You can't calculate the correlation between a person's gender and their yearly income or your major and your GPA. It doesn't work, right? I need two quantitative variables. Now, that's just a setup. One is you can flip-flop and nobody cares. Correlation doesn't care, right? What we do care about is you have two quantitative variables. Now, 3. Here comes the direction. If the correlation is positive, in other words, you get a positive correlation, you get a positive association. If the correlation is negative, so what I'm telling you is the sign of the correlation will tell you about the direction of your relationship. If it's positive, you're seeing a positive association. If it's negative, you're seeing a negative association. So to me, this is about the direction. And then 3 is this is always true. The correlation is always between -1 and 1. So this is about the strength here. So here's the way I think about it, and the way you're going to see me talk about this next Tuesday is here's -1 and here's 1. The correlation is always a value between them, right? The closer you get to 1 or the closer you get to -1, the stronger the linear relationship. Remember, the sign is only telling you whether it's a negative or positive association. The closer, so in other words, here's 0, here's -1 and 1. As I go this way, the stronger it is. The closer I get to 0, the weaker it is. And actually, the closer I get to 0 and I'm close to 0, we tried to do the wrong thing. We were looking for a linear relationship and we didn't have one. Right? So, closer R is to +1 or -1, the stronger the association. If for some reason you would get a +1 or a -1, you would have what would be called a perfect linear relationship. In other words, if I put a ruler on your scatter plot, I could just draw a line through all the points, right? They all lie exactly on the same line. If you're +1 or -1, it's just depending on whether it's positive or negative. Other than that, the closer they are, the closer you are to +1 or -1, the sign's just telling me whether you're positive association or negative association. Close to 0, we wasted our time. We didn't have a linear relationship. We tried to. Okay? Now, when we come back on Tuesday, somebody remind me this. What I would like to do is this. I would like to draw you a little number line. Right? And I'd like to give you some language depending on where I'm at here in terms of, are you weak? Are you moderately weak? Are you moderate? Are you moderately strong? What the hell is very strong? In other words, where do I start looking at things where I can give you just a little bit of language there, right? So we'll start there on Tuesday. Rob's got your homework to get back to you. Don't forget my homework 3 for Tuesday. And we will see you folks. Be careful going to the house, and we will see you folks on Tuesday. Yeah, I just need